welcome back. We're going to do Java 2D graphics. Hello. We're going to do Java 2D. That's why we shut the door so I can hear myself. Alright, so topics in this particular lecture, this is actually kind of interesting. It's not swing, it's not AWT, it's 2D, two-dimensional Java graphics. So what you're looking at is 1, 2, 3, 4 examples that I'm going to show you in a few minutes that are out in the files that accompany this lecture. It's a pretty lightweight lecture. It's just showing you some capabilities. And if you open up the Java 2D file that gets downloaded, you'll see a bunch of files in here that are precompiled for you. The ones that end in example are the ones that are going to show you something. The rest of them are used inside of them. These are not applets, these are Java programs. And the Java programs are using the Java 2D libraries. So it kind of gives you some more options as well in terms of some of the things that you can do with Java. And these, by the way, also work on the Android. So the same code that you're writing will actually stick out onto the screen, the same object, the same thing. So you can write this in Android applications as well. So overview here, drawing shapes, paint styles, transparency, local font usage as well, coordinate systems, and transparency. So this is, again, on the... I'll just wait. Okay, thank you. Just wait until I got a little quiet. There's not too many people in here. Why is this so loud? That's the weird part. Alright, so here's the AWT versus Java 2D. So again, this is not AWT and it's not swing. I do have some additional swing stuff I am going to show you though in a few minutes as well. But if we compare the two, what we're looking at here is a super.paint graphic G versus G. In the paint version of the AWT, very similar. It's using graphic G. So G. Set font, get font, drawstring. These are some similar methods that are over here, except for over here we have G2D, graphics 2D. So it's a separate graphics package that's used for two-dimensional graphics. If you're going to use three-dimensional graphics, then you're going to use OpenGL, which is also supported on the Android platform as well. So the Java 2D drawing process, step number 1, cast the graphic object to the graphics 2D paint object. So paint component, graphics G, and then we have the super paint component G running the supers, excuse me, objects paint component G. As we saw earlier today in our review, the super dot something is going to run the method from the super object, which is going to be our graphics component in this particular case. And then we make a new instance of the object. So we have graphic 2D. It's going to be G2D. So some people think, well, you know, why do we have to run 2D? Why do we need this? Well, sometimes there's not an image that exists. You just want to draw a circle. You want to draw a box. You want to paint something. That's what this is really good for, actually. So note all the methods that return graphics in Java return graphics 2D in Java 2 and later. So it only works in Java 2 and later. We're looking at paint component, and get graphics as the components for it. Here are some sample methods, and sample methods we're looking at is a set paint, set stroke, set composite, set font, translate, rotate. I'm not going to go through all of them because they're kind of boring at one point, but in terms of what we're doing is we're going to draw something using the drawing process with G2D dot something. And then in step 3 we're going to create the shape. So the shape object itself, here's a rectangle. So what we can do is create a polygon, a rectangle, a sphere, something, and then put the shape out because we have some predefined shapes. So very similar to, actually very similar to OpenGL if you've ever used that, where we have predefined shape components and we make a shape and we add some color and make some properties associated with it. Most shapes are in Java AWT geometry package. So there's a bit of an overlap with AWT. This is not swing related though, it's AWT, Abstract Window Toolkit. So there's a corresponding shape class for most of the Java XX methods of graphics, which is a different library. So here's the built-in shape classes. Arc2D, that is going to be specified with the double, the float, the area, eclipses, and we'll see these live in a few minutes in a couple of examples. So draw an outline and fill in the version of the shape. We go G2D.draw. .fill. Legacy methods are still supported from 1.0 all the way up to 2. The drawstring will commonly be used, which is like the hello worlds for applets, actually, which is what we saw a few minutes ago with the g.drawString. Share some example code for it, and what we have is the shape example, which extends JPanel. So if we remember now we're looking at swing for JPanel. If you remember the swing stuff, the good thing about the graphics packages as well as swing and AWT is it all can be used together. So here we have the geometry package along with AWT, along with swing. And so in here we're going to extend JPanel. So everything J, actually there are some swing questions on the final. You remember the differences between the two of them? Actually, for all the people who left, this is for your benefit. So swing is not supposed to be platform compatible. AWT is platform, it is dependent on platform support. The swing is not. It's supposed to be cross-platform. So as an example, if you're using AWT, you're going to get the frame that's going to be for a Windows system or a frame that's going to be for a Mac system. You're not going to get a generic. The swing was an attempt to make it more generic, but swing is built on top of AWT. So bottom line, none of it's cross-platform compatible, actually, when you think about it. Which is why people supplement it and they bring in the geometry stuff if they're going to do something on top of that. But the frame is the frame is the frame, though, and that's the problem. If you use frame versus JFrame, you have two different sources from two different packages. One of them is going to give you a slightly different motif. The AWT is going to give you a motif that looks like the target platform because it's going to write directly to the operating system. So it's going to look like a Windows box. The swing version of it is going to look like a Java box, or Java frame. So that's basically the only couple of differences between the two. You're not going to be asked questions about any of the particular packages or any of the calls, but you know, we have J buttons, J text fields, J panel, J's in front of everything. So, all right, so here's the shape example. And the shape example here, we're looking at the code. In fact, I don't think the shape example is even out here, but we'll just see real quick here. Yeah, shape example. So if you run shape example, it's just going to be a circle inside of the box. It's going to come up. Not an applet. It's a Java program, actually. So, little box, it comes up with a little circle inside of it. And it's just because we extended JPanel, and then we have a Eclipse double circle that's going to be in there. And the circle is going to be filled with black color. So, and then we paint it. We fill the circle, draw a square around the circle, actually. And then we get the square around the circle. The idea here is that we're going to set the set paint and the get paint to change and retrieve the paint settings, and noting that the set paint and the get paint supersede the set color and the get color methods that we use in graphics, inherited from Graphics 2G. So, and then the fill, which is very similar. Actually, if you look at the syntax, it's very similar to what you see in other languages as well. The fill component, it's very OpenGL-like too. The draw, the fill, you know, which is kind of interesting. So let's see. When you fill it, the current attribute for the 2D object is used for that. Possible arguments might be set a color to fill in a particular color, granulant, textural, I don't know, and any version of the paint that you want to write to yourself. So. In terms of the detail, I'm not going to go through all of this, but we have preset colors we can set, and the colors are going to come from an AWT version. So just like the AWT version, we're going to have extra, you know, color.yellow, color.red, color.blue, predefined colors. We can also set the RGB scale of the color. Different types of paints that we can use to give different textures or non-textured looks. I mean, obviously, it's depending upon the monitor quality as to how it's actually going to look. In terms of simple colors here in the paint, color red, color blue, color yellow. We can also have an event handler that's set for it. Here's the mouse pressed event. It's going to change the color. And this is the granulant paint example. So rather than looking at it, we'll just see the finished product on here. Gradient paint. example. So we have, this one does not have a mouse event on it. If I click the mouse, it doesn't do anything. But we can kind of sort of see, probably you can see, actually it looks really good on the screen up here. You can sort of see how the texturing has changed versus, I don't remember what the other paint one is on here, but there's another paint to it that's comparing it as well. So maybe it's transparency, actually. Let's see. Nope, that's going to be a different one. Transparent color down here, and then setting the level of transparency, actually, with this particular example. There's some pretty interesting examples, actually, in here. So let's see. Yeah, that's the gradient paint. So that also have tiled images as filled patterns. So create a texture paint object, and then construct it with an image, buffered image. And so select an image that you're going to put in there. Create a rectangular 2D object, put the image inside of the rectangle. And I use the paint method to specify the texture paint for the object and how it's going to be displayed. And then you can apply a string to it, draw a string on it, draw some other shapes on it. Create a buffered image or a custom drawing to use with it. So here calling the buffered image constructor with a width and a height, as well as the image itself. So, and let's see which this one is. This one's loading the image. Actually, there's an image out there that gets loaded into a box that has some other things written on top of it, some other shapes. And it's showing you the buffering so that if the image is loading as well as some of the graphic components, you want it to all load together. So you use different method calls to buffer it so that it's being kept until the entire image is painted, so it all appears simultaneously instead of the image showing up last or first. And so if you think about the way some types of web pages load or some applications load, you want it to seem, although we have different components on there, you want to seem as if it all loads together versus one loading and then waiting for the rest of it to load. So in terms of creating a buffered image from an image file, you're loading the image from the image file via getImage method call. You can use the media tracker until the media, to make sure that the loading is synchronized with the rest of the activities. Create an empty buffered image using the image width and height. Then get the graphic 2D by the creating graphics method as well. There's also a utility class that works with this. The process is wrapped into the get buffered image. So image utilities, the example code here is going to essentially load in a buffered image and show you how to actually create a buffered image using the code. And it means nothing to look at it, so probably better to, here's the tiled image, probably better to just see the examples, I believe. Let's just take a look here. This one's going to have the textured paint on it instead of the gradient one, so I believe that's this one here, which is the tiled image with the filled patterns, which I believe where we have the image loading on top of the circles that are inside of the triangle with some coloring allowed. Actually, there's an image for the background of that triangle, and there's an image for the picture of the guy sitting there. And I believe that one is the Windows utility. Window utilities. Let's see if I spell it right. Window util UTIL. Where's my misspelling? Here, we'll do that this way. Oh, there it is. Yep. Let's check where I am here. Well, I know I loaded it a few minutes ago. Maybe it's image utilities, actually. Image utilities. Oh, you know why? All of the examples are actually in files with the example name on them. So that one's being loaded by, so all of the class files themselves are working together. The main menu, the main init method is for the main execution is happening in the ones that say examples. So let's take a look at stroke. Transparency image is probably going to be in one of the example files if I could find it. It's not really that big of a deal. I just had it loaded up a few minutes ago. It looks like this actually when it loads up. What we're looking at is an image inside of, in fact here I can just run through my buffer. It's not that one, it's not that one, not that one, not that one, not that one. Shape example, nope, not shape example. It's right before that one. During the break I had it actually loaded up. So I know it's in here somewhere. Just have to go back further. Nope, not font example. I think it's right before font example actually. Probably some better naming convention would probably dash stroke. Nope, that's not going to be it either. Anyway, it's in here somewhere. It's one of these examples. Better naming convention would probably, our numbering system would probably help with that. But anyway, it's demonstrating how to buffer the image so that it all loads together. When you see it load, it comes in as one image instead of all of the different pieces that are layered on top of each other. And this is an image that's buffered inside of the other shape, and then this image is an image that's buffered and put inside. Which one is it? Tiled images, yeah. So there's probably a tiled images example out here. Yep, no, tiled images. Let's see. I believe it was supposed to be called example, though. Let's see, tiled images. Yep, tiled images. No example next to it, of course. So again, the naming can probably be improved with this, but it's kind of interesting how it loads up. It does actually loads up simultaneously, so when it does appear, it appears all in one shot, which is interesting because it's buffered. So the whole entire thing is prepared before it's actually shown, before it's displayed. So then we have transparent drawing. Transparent drawing is basically setting the background transparency. So assigning a transparency or alpha value to the drawing operations, which is kind of common these days. So partially showing through, so you can see something underneath showing through the main image, creating an alpha composite object itself as well. And again, what we're going to be doing is loading up an image and sticking it into a transparent object so we can see through it. And then we're just basically setting the methods, setting the make composite to the alpha transparency. Which is this one here, we just saw it a few minutes ago actually, where no transparency is going on, a little bit, then a lot down here. Which is one, the red being put on top of the blue and being able to see the blue through the red. In that particular case. Java fonts itself, making, in fact there's a window that comes up with a circle and I think it says Java on it actually. There's a screenshot of it in here. Being able to set the fonts of the system. One caveat in here, I believe it's going to tell me down here, is waiting for the fonts to come out. So get all fonts from the environment is going to take a while because you're working directly with the underlying operating system. If you just assume and set a generic font, if the font's not there, it'll find a closest match and load that one. So it's a little bit faster. So there's different ways of getting at the native font system and the types are associated, because what you don't want to use is a font that doesn't exist on the operating system, and then when the program loads up, it gives you some sort of an error or it doesn't look right. In fact, the one on this machine is actually kind of interesting because when I run the font example, my font size is bigger, so my Java 2D extends past the circle on mine because it's not actually running. In fact, see if I can get this one. This is called font example. I can get this one. So if I do font example, I can see that my font size on here is bigger by definition, so it doesn't really matter if I take this here because it's not it's not the window that's causing it. So if I were on a Windows system, I might actually see that correctly. Or if I were on a different operating version of this operating system or something, which is one of the problems you run into. If you don't want that to happen, you get all the fonts, you find the ones of the same compatibility or the same size, and you set the size and load it in. This is just using a generic size, but the size definition is different on my target platform, so it's using whatever's on my system to generate it. So it's not like storing it, it's generating it on the fly when it actually loads up, which is kind of an interesting thing. It creates the illusion that it's part of the image, but it's really just a font that's being used to draw a string, and the string that's being drawn right here. So I could change the size of the string to accommodate the size of the font usage. So that's one of the things you're going to run into when you start doing this, the 2D. It's going to look slightly different depending upon what kind of font might be on the system. So we also have stroke styles. In terms of the overview and comparison on AWT, it's drawn with XXX, which means essentially putting a parameter on the method, results in a solid 1 pixel line. Predefining the draw, the join, and the cap styles, capitalization styles for the redrawing as well, and draw polygons is able to be run. In Java 2D, we're looking at thickness, pen thickness, and we're also looking at dash patterns versus undashed patterns, line joining and capping styles. Same, very similar to the AWT. So we can set styles to create basic stroke shapes on objects as well. And then here's some generic stroke attributes. We can see differences with the dashed line versus the solid line, which is going to give us a different stroke. So in here, the ones for that are going to be the circles, I believe, or the circles with dashes. Line styles, actually. I don't remember which. Oh, here, dash stroke example. It's actually the one with the dashed one. So it's going to give us a dashed line that's around the circle here instead of it's the same example we just looked at before, but instead of drawing the circle, it's using a dashed stroke. So it just gives us different effects by running different methods to actually draw the lines itself. So, and again, you're not going to be testing it in any of the methods. It just basically gives you kind of an overview of how the things are, how the packages can be used. Using a basic stroke here is a wide pen, and so there's another one in there that's going to show you a non-dashed basic, and then we have the one that has the dashed in it. So this is going to be a dash pattern that's going to be set for it, which gives us the dash pattern. So kind of interesting. The joining styles, you join mitter, bevel, and round, which is going to give us different effects in terms of the line quality and connecting the pieces. So cap styles, cap squares, cap butts, cap round, different styles. Again, you know, not everything is going to be represented, but most of the common characteristics of the graphics will be. So. This one here, don't know. This is line styles, actually, which are going to show us the differences in terms of the different types of edges for how the line should be brought together. I don't know if line styles is actually in this example, but let's take a look here. It is, actually. So if I type in Java line styles, can we keep the talking down in the back or take your conversations outside? That way I don't feel like I have to talk over you. Thank you. So it's a slightly different. The join here versus this join is what we're looking at in terms of the squared off caps or rounded caps or beveled caps. So if you really want to get nitty-gritty about your drawing styles. So when are you going to do that? Well, you're going to do this probably as a fix. You're going to have an image that comes up and you're going to put a box around it. You want to make it look like the other boxes. You're going to want to make it, you're going to bring two lines together and you want it to look like one object or something. So it just gives you choices, essentially. And let's see what we have down here. Coordinate transformations. This is on a 2D. If you're going to take this graphics to this level, you're probably going to go on a 3D instead and start looking at OpenGL. And then the transformation metrics is going to be able to, let's say, take a line and move it, transform it, rotate it, do all sorts of different special effects with it. Again, 2 and 3D packages is kind of primitive to a certain point, but it does allow you to do some basic functionality. Here's taking the word Java, printing it out, translating it, rotating it, and then printing it out again. And this is the rotation example. It actually looks cooler on the screen. Actually, I believe it's called rotation. Yep, it is rotation example. But you can see that mine is a different font size, so it's going outside of the. But it's really taking one word Java, translating and rotating it with using a transformation matrix, and just keep rotating it around in a circle, 360-degree circle, and then repainting it. So it kind of gives you a nice, really cool effect. And it just kind of comes into the center, interesting, because you see this is the J for Java, and because of the way the font is styled, it actually looks pretty cool. A little wheel in the middle with the J. So. Anyway, you can play around, change the word to another word, put it out there on the screen. And, the code for it's fairly straightforward actually. But here instead of Java, you could put something else in there, like your name or something, and see what that looks like. Java looks pretty cool. A shear transformation, so you can get different effects with the transformations. That one's not transparent. It's actually not doing anything. It's not shearing it either. It's just making it into either white or black text and just rotating it. You can use an X shear to specify the non-zero X shear or different values to write to change the effect of the shifting to the right or to the left. And then the overlapping and the percent of transparency between the overlapping images. Overlapping words. So note that the skew instead of shear is done with the graphics library with Android drawing. So the Android drawing library is practically identical to this. It is just the core Java 2D translated into an Android compatible format. So the same capabilities exist. So people, I would probably say that people use the Android draw more so than the Java regular 2D draw, because it's for games and for special effects on apps. It comes in a little bit more handy for the most part. So, applets aren't used so much, but draw package you use a lot actually in Android. Why? Because there may not be an image, or there may not be something where you put a title, a label, some image that you want to create using a 2D graphic. So you can come up with some pretty nice effects. One of the things I've seen done recently actually is taking pictures from the photo library, from the picture library, and then rotating the pictures, or having some interesting translation go on with the pictures, which can be done fairly easily, actually a couple lines of code. So, can you find a library package to do it? Sometimes not, actually. So if you take the 3D approach to it, you can come up with some extremely nice looking screen flipping. So you can actually sort of emulate the iPhone in a primitive kind of way on an Android system. So there's no comparison to iOS with that. iOS is definitely a higher grade level of graphic, because the operating system itself is supporting a higher level of graphic 3D. Because iOS supports OpenGL and then native form through Objective-C with a lot of garbage collection. Java does an okay job, but not quite as much with the OpenGL, and the processor generally is a little bit not quite as optimized. Because if you can take, it's sort of like a camera capabilities. It's all dependent upon the hardware. Well, so is the graphic processor and graphic CPU and memory. So if you make it a graphic intense 2D, 3D kind of animation on an Android phone, you're not guaranteed to have the same hardware on every single device. And so the buffering, the flickering, the effect is not necessarily going to look the same or look at its best. iPhone, you have much better luck creating a higher end, consistent look and feel over device, because there's only one or two devices. You don't have to support every device out there. So. Which is why people who get into it are generally iOS developers that will do the graphics on the iOS. So. Not to say you can't do it. It's easier to do it, a lot easier to do it on an Android platform. Just don't get, when you're looking at special effects, graphics, and painting, you're not getting the same quality overall. In general, if you have, just to summarize this here, if you have a graphics casted to, if you have graphics casted to a graphics 2D library, create drawing shapes and things of that nature, arcs, circles, fonts. We have different paint styles that you can select as well, different colors as you've seen in some of these examples. And we have transparent drawings as well. You can use the local font system by specifying the font family. And again, when you supply the name of the font and specify the font via the set fonts. We have different stroke styles. We have different coordinate transformations as well. Good luck with that. And then some rendering tips, improve drawing quality or enable anti-aliasing, and use buffered graphics, buffered images for the most part. So that was your introduction to the 2D libraries that exist for Java. That's part of the core Java system as well. So just like applets, it's kind of an introduction to it, just to give you a feel for it. Nah, no, 2D. When you get into 3D, OpenGL is sort of the de facto standard for that. So OpenGL works with C, C++, Objective-C. I think there is for Java. There's no Java 3G. C++. Well, no, I thought there was like a beta version of it out there, like a test version. Traditionally, OpenGL has worked with C and C++. It was adapted, and when iOS came out, it was adapted for Objective-C, which Objective-C is backward compatible with C. So you can take C libraries and transform them into an Objective-C. Somebody had once told me that there's libraries for, I've never done 3G, or excuse me, OpenGL with Java. I've done 2D, and the Android system supports the 2D libraries. It doesn't support OpenGL. It doesn't. Well, there are some ways of getting OpenGL to work. It doesn't support it in the same manner that iOS supports it. iOS has it built into the APIs because it's C-based. So in Java, you're looking at 2D and graphics library. So what is that going to give you? Going back to what I was saying about the hardware, you're not going to notice most of the 3G stuff anyway. Not to say that Android systems aren't quite as hardware compatible as the iPhone, but if you just take the two products out of the box and compare them, you're going to go ooh ah over the iPhone. You're going to go okay on the Android. It's just the quality in the manufacture of the device, the hardware, the buffering, the graphics system. Things look smoother, things look richer on the iPhone. It's the industrial design of the product for the most part. And it supports true 3G, which means you can have virtual reality, images, all sorts of different stuff that's going to flow smoothly and run great. You take and compare that a $500 device with a $99 Android thing. You're not going to get the same graphic processor on it. You're not going to get the same buffering capability, not the same memory, not the same hardware, not the same configuration. Because you're looking at 3G, you need graphic processor. You need a lot more hardware to support the graphics than you're going to get on a lower, on a more practical device. Let's put it that way. So to answer your question, no. Although I heard that there's a version of it out, and I hear there's we'll Google it real quick here. I'm kind of curious now, actually, if it's out there. OpenGL for Java. No, look at that. OpenGL for Java download. Where can I download OpenGL? Joggle. Maybe there's a link in here. OpenGL for Java? No. Java building. Yeah. Binding for OpenGL. There is an API for it. Yeah. Not integrated very well into a lot of different packages, though. So it does minimally. I don't know. I'd never tried it before. When I think of OpenGL, I always think of C, C++, Objective-C, iPhone. So I've never done it on an Android before. But personally, you know, people out there are going to start complaining and they're going to go, oh, you can't say it doesn't support it. So yes, it does support it. So you might find some luck with that. So. Okay, so I believe this is going to be our last lecture for today. It's going to be on AWT, which will end us, you know, probably a good starting point for tomorrow. Also continuing along, this is a little bit more stuff that on top of what I've given you before. I want to talk a little bit more about the AWT libraries and the GUI controls, because we're on the GUI topic right now. We know about the canvas and the panel and the frame, but I want to kind of review a little bit of this. This is more along the lines of again, recapping for final exam purposes for what we saw in the first couple weekends. So closing frames, processing events using the GUI controls, basic UI interface controls, checkboxes and stuff like that. We focused a lot last time on the notepad. I think we did like 7 different notepads, which was kind of limited. Didn't really give us a lot of the, you know, didn't give us the full library. Are you going to get the full library? Probably never. We're never going to use everything in AWT or in Swing. Let's take a look at the two. You want to know that AWT stands for Abstract Window Toolkit. You want to know that Swing stands for Standard Widget Toolkit, which is what Swing, SWT, excuse me. Swing is the GUI library added to Java starting later. So 1.1 Java, which is it's significantly long ago, but it wasn't the original. So AWT was actually the original part of the Java software SE or SDK, the original JDK. The extensions for SWT for Java FX also exist. In fact, you can download Java with the extensions as well as part of the options. These are the two we focused on last time. I'm going to introduce a little bit of these concepts here for widgets and things, but primarily for exam purposes, AWT and Swing are the two that are mentioned down there. So original GUI library. Purpose, easy building, simple making, looking interfaces, yes. And first step towards learning Swing is to kind of get familiar. You can't use one or the other, you have to actually use them both together. One's built on top of the other, Swing is built on top of AWT. Purpose for Swing was to make it more professional, make it easier. A lot of people complained about AWT in the beginning. Well, it's kind of limited. It looks like a Java program. Doesn't look like a native application. And they're right. And then all of a sudden we came out with Swing. And it was an improvement. So are they going to do the same thing? Yes. Are they going to be compatible? Yes. Are they going to provide everything they could possibly want? Probably not. So we have extension libraries that work on top of that. So GUI here for Eclipse Foundation. So you can download versions of Eclipse that have SWT. You can download Java FX, actually, right from the Java Oracle website. Standard libraries, purposes for XML-based layouts, mobile platforms, rich media, audio, video, which is what the special effects are going to give you with Java FX. So, windows and layouts. Remember, and this is again review for our final exam for tomorrow. We have the concept of containers, layout managers. We saw the layout managers. They're the similar contrast that we saw with the Android. Remember the layout, the border layout, the linear layout, the relative layouts. Those are layouts, which are the same ones we use in non-Android applications as well. Most windows are containers. They hold other items. So a container, just like it sounds, is a container. It's going to hold everything. GUI components. We have the canvas, which is a major exception to the container concept. It's the window canvas. It's the container for the GUI components. They're not holding other windows, or that is the window. So the layout managers themselves contain the layout manager that automatically sizes, proportions, makes things look relative to another thing. So we know that the linear puts everything in a line, the relative puts this above this one, below this one, to the left, to the right. So you can change the behavior of the layout managers and disable it completely if you want to. Then we have the events. Remember the click events, on-click events, listeners and stuff like that. Windows and components that can retrieve mouse and keyboard events. So drawing windows. So this is, okay, so AWT and Swing, well, they both work together, but they both are on top of Java 2D. So 2D is the base foundation for it. So we still have paint, draw, redraw. All those concepts are extensions that are created in AW2. So we started out with 2D, then we ended up with window toolkits. And we ended up with GUI components. Why? Because we want to make a window with buttons and components on it that look like other windows in our graphic packages. And we just don't want to draw circles and ellipses and words and stuff. But we can use them both together still, which is kind of interesting. So to draw into a window, make a subclass of your own paint method. And then having one window draw into another window is not generally recommended because it adds too much of the layering, and one's going to overlap the other one anyway. It's going to slow down the processing. We have pop-up windows, or windows themselves. Those are the J-frames, the frames, the dialogues, the J-dialogues. They have their own title bar, their own borders. This is what we looked at before when we created the frame for the notepad programs. Other windows, we have the canvas and the panel that's embedded inside of the existing windows. So foundational AWT window types. Canvas. So the purposes of that is to have the reusable picture of the drawing area. So canvas is just like what you'd possibly imagine the word meaning. On the canvas you can actually draw. You can do the 2D drawing on the canvas. You can actually put other things on the canvas as well, other components. In the code you can allocate the canvas, give it a size, add it to existing windows. The panels is a group of other components into rectangle regions. We have the southern, the northern, the eastern, the western panel. So we divide out the window into panels and we add stuff to the panels, which makes it easy. And then the frame is the core pop-up window. It's what all the stuff is going inside of. Main window itself and the frame, so the code is to size, resize, pop it, remove it. So in terms of the canvas, the major purpose is the drawing area. And then the other components that does not need to contain any other components. It's just like this, for example, an image button or something. Default layout manager, we don't have a default layout manager for that. The canvas is not a container, so it doesn't include its components. It basically rides on underneath it. So creating and using it, we allocate it. Canvas C is going to be equal to new canvas, just like any other object actually, which is kind of interesting. It's object-oriented programming. Give it a size, set size, get size, setters and getters. So here's our canvas example. The class circle, which extends canvas, and we have a circle component that's built into the canvas in this example. So if I go out here to the AWT examples, I should have a circle in here. Better circle test and circle test. So I see some of it's going to be in the form of an applet. Some of them are going to be applications, depending upon what we're looking at. Let's see. Yeah. Here's the circle. We're going to have a circle test and closable frame. So this is where you're going to find the items. I'm not going to bother with going and searching through and looking for them. Instead, I'll just point you to where they are. And later on, if you have an interest in it, you can go back through and run it. But there's screenshots of every one of the running programs in here. But in the example, it looks like this. The circle test, it draws 3 circles onto the canvas. This is the code for it, actually. And so what we're looking at then is extending canvas in the hierarchy. So this is regular old inheritance. We have the private integer height and width, and we're going to set the height and width to, we're going to have public circle. So circle is extending canvas. It's a type of canvas component that's just going to paint a circle. And we're going to use a g.fill oval, create an oval at the starting position 0, 0, upper left-hand corner, and then go out to the height and width to the size. And then in our applet, this is circle test that extends applet. Then in here we're going to add a new circle. And the new circle we're going to add is going to be color white, color gray, color black, and then the size of the circle. Because our circle constructor takes the color from the foreground and then the radius size and the integer. So we send it a color and then we send it a size. So we have color white, color gray, color black. So it's just the same type of programming as I've been talking about all day actually. It's just creating an instance of an object. In this particular case, we're doing it inside of an applet. So we're running init instead of main. We're setting the background of the applet window. We're creating 3 circles here with a new circle, calling a constructor with a color and a size. So we have increasing sizes here going on. And then another one, circle test number 2, using the same circle class. Here we're going to go circle, circle, use the default constructor in this particular case, and then set the radius and set the dimensions, and then paint the circle. So circle is going to be equal to here a new circle with this size and that size, and then we're going to add the circle to the canvas, which is self. So actually, I'm sorry, to the applet window. So in turning off, this is the interesting part here, we're going to set the layout to null. It turns off the layout manager and makes it so that we have a free-forming layout controller. So what are you going to do? I'm sorry? You'll have to do it at the end. Alright, so here we have the circle.setCenter, setting the center to a particular location. So lightweight components, in terms of the idea, regular AWT windows are native windows behind the scene. So they are regular rectangles and opaques and all sorts of different objects that are built in. So we make them into lightweight components that are really pictures, not windows. Which is kind of like what we did here. We kind of created lightweight components or circles that we're displaying. So these don't really have rectangles or opaque restrictions, but the building them is usually more troublesome or worth in terms of the AWT library, which is why we use different libraries for it. Swing libraries make it simple with the set opaque method. So we have some built-in functionality to automate some of the window features and some of the images and some of the graphics for us. So if you really want to do it yourself with AWT, you have to tell Java what to calculate, minimum sizes and things of that nature. Or you can just use Swing instead. So Swing came along to kind of make this more automated. Swing is a higher level API written on top of AWT that has built-in methods and different types of objects that create different components. So we have a frame, and then we have a J frame, and then we have J components, which essentially is going to add more functionality and give us more capabilities to automate it a little bit. So they're not quite as lightweight, they're more reusable in terms of the concept. So we have the component class that came about. The component class is the idea is give it some context. So the ancestors of the original graphical components in Java, even in Swing. So methods here are shared by all windows and class controllers. If we do this, then we can put listeners on there for events and for other activities. Useful methods might be to set the background, set the foreground, change the lookup of the default color itself. So the color is inherent in the graphic object of the component. So set color, set font, and also the paint is in there as well. So useful methods here might be, and we've seen these actually, we saw this when we looked at the notepad examples. So set visible, set size, set background, set location, things of that nature. And then list, which prints out the information of the components that are contained and any of the components that are useful for debugging. So validate, invalidate, show, not show, hide, redo the layout. And then get parent returns and closing window of the parent. So of the hierarchy that we saw, just to review the concept, component was the outer, and then inside of component we have the panel, and then we have the things that we can load inside of the panel. So the panel, main purpose of that is going to be for the grouping of the components. So we create this abstraction, and then we use the abstraction by nesting the components, I shouldn't say component, by nesting the items together in a hierarchy, and then we can create our abstraction. And bottom line, as I mentioned last time, if you think this is complicated, then get one of those Java GUI drag and drop editors. And then you see it actually does all this stuff for you, instead of using like Notepad to create a panel and create components, and use the layout managers and do it all manually. If you do it that way, you have less code. If you use one of those higher level drag and drop kind of, it's kind of like when you create a website the same way, you know, drag and drop stuff on there, you have like twice as much code. That's what you get with the drag and drop swing editors too. And there's a ton of swing editors out there, but they all add their own little classes and code. And if you don't pay for the swing editor, you get like a free copy of it, then they'll insert their little logo or something on there for you. They'll add stuff to your display as well. But they also automate things. So it depends on what level of comfort you have with programming in general. But a lot of people will use the swing editors because it's just easier. It's a lot of manual code writing that doesn't make very much GUI sense in terms of the development effort. So, which is kind of interesting. And it's sort of interesting as well how in the Android platform we went away from this whole Java concept and just went XML. Because the interface for the GUI components is XML based in Android. So you take all that XML stuff, you put it into the resource directory, r.java file, you link the Java code associated with that, it translates it into something very similar to this when it writes the code. So what we did is instead of having to deal with, because I don't think there's a lot of Android developers out there that could handle writing the windows and the panels inside and the layouts editors and all the other things. So I actually thought it was pretty nice that they have the XML interface. So now we have XML swing editors and XML editors that create the Java for us in non-Android applications, which is kind of interesting. So anyway, a bit of trivia for you. But the panel, the major purpose of the panel is to organize and group the components together. And then we have the default layout, which is the flow layout. No, you have to wait until the end of class. I have it, but you have to wait until the end. So, the default layout manager, or the flow layout, as it says, shrinks the components to be the preferred minimum size, places them to the left or to the center in corrected rows. So we create and we use it, we allocate it, an example here of allocating a panel, panel P is equal to new panel. You can do the same thing with components, and you put stuff inside of it, p.add some button, p.add some other button. And then we drop the panel into the existing window, we're going to say some window.add p to it. So the add method is used to nest the components for the most part. Here's an example of no panels. And this no panels example here, we're going to take and make an applet out of it. So we have button test 1 that extends applet. Hold on one second. Alright, sorry about that. So what do we have here? This is an example of button test 1, which it should also be in this folder over here. We should have a button. I'm not going to run it, but I'll save you on that one. But it's going to either, oh, this is the different one. It's going to be in the samples folder here. In here we have a ton of, here's your button. So there's a button test 1 right in here, which is going to run as an applet. So if you're interested, I don't believe it's actually going to, it's not going to show in here. Instead I get the title that's in the HTML code, so I'm going to have to run this in the applet viewer. Actually, it's not a bad idea to see. It will, security warning. The application located on your computer is requesting permission to run button test 1. That was a bit delayed, but it actually does work. That's the policy file. I'm going to say, well, let's see. Yeah, let's run it. Let's see. I will probably, now that I've given it permission, it will probably work. Here it is. It does work. So the first couple of times I ran that, however, it was looking at the wrong security policy. This one actually works. So you have to set the security policy to allow it. So it's just, I'm going to start thread, stop threads. It's just basically putting a bunch of buttons into a panel and loading the panel onto the window on this applet window here. So it's just a bunch of buttons. So, but long story short, that is one of the more interesting examples that's in this example set because it adds a bunch of buttons essentially. And it puts a label on the button. I don't believe it actually is doing any thread programming. So this is what it looks like, actually. So we have panel P1, panel P2, which is going to be our 2 rows, or 2 panels actually. And the new button with the prefix for thread 1, thread 2, thread 3, thread 4. Thread 1, start thread 1, stop thread 1, pause thread 1, resume thread 1, etc. and so forth. And then we have the container class that works along the same in terms of set of classes. So the ancestors of all of the window types except for canvas. Canvas is an exception to that. So the methods are common among all the different windows that are associated with the container. Useful container methods are add something to container, remove something from the container, get components, set the layout for the container, go to flow manager, or something of that nature. So, and then we have the frame class. So containers, and then we have frames. Major purpose of the frame class is a standalone window. We've seen the frame. We needed to create a frame for the notepad example, actually, or for the notepad assignment. Has its own title, has its own menu bar, its own borders, its own cursor, its own icons. Can contain other GUI components as well. And the default layout manager for that is the border layouts. We can change the layouts easily, however. The border layout divides out the frame into those 5 regions of north, south, east, and west. So we can put panels in there as well. Put a border inside there and change the flow or the layout for each one of the panels. Creating and using them, there's 2 approaches. We can use a fixed size frame, or we can use a frame that stretches to fit what it contains, depending upon how you want to do it. Make it expandable. So in terms of the approach, we create a new instance of the frame. So frames are going to be equal to new frame. Give it a string that's going to be the title that's going to be used for the frame. And then add all your stuff to it. So we're going to add some panel to it and set the layout to this. Add another panel, set the layouts. And then set the size if we want. And then this is the other step as when we went through the notepad example. We commented this out, if you remember, and set the set visible or set it to false. Don't set it at all. By default, it's set on false, which is kind of, you would think that it would just show up automatically, but you do actually have to set it to be visible. If you don't do that, you actually don't see it. So, which is kind of interesting. Be sure you pop up the frame last, actually, as well. Otherwise, nothing is going to show. So, which is kind of odd behavior results if you add components to the window that is already visible, unless you call the do layout on the frame and load the frame again. So, which is kind of interesting. So, creating a frame with stretches to fit what it contains. The other approach. So, this approach here is just going to set the size for you, the height and width. The other approach is to make it expandable. Frame.pack takes all of the components, orients them, and positions them inside of the window. So the pack assembles everything for you and then makes it visible, which is if you're going to have everything auto-adjust, you need to pack it. If you don't, you actually will experience the same effect. So there are pros and cons to using the pack. Pack will actually clean up the memory, set it, adjust it. If you don't pack it, depending upon how the size of the window is set, you might get the components smaller inside of the window. I've seen that actually with a lot of applications. When you make it bigger, the window goes bigger, and then sometimes it refreshes, and sometimes it just sits there, or you see part of the window readjusted and the other part not adjusted, depending upon what's going on. If you run the pack, it fixes it up, cleans it up for you. So again, you can make sure the pop-up of the frame is after adding the components to it, because if you don't add it last, you end up with an issue. So I'm not going to run this one, but we have 2 examples, one with a fixed frame that loads up, 400 by 300 in size, and then there's another with an auto-adjusted one. So using extending frame, so frame example number 2 extends frame. This one just it's essentially going to create the fixed size frame of size 400 and 300. So the closable frame puts the little X button on the window, makes sure that you can close it. So it adds the window motif for the closable icon. And so you're going to, here we're going to set the title, we're going to run super title because it's from frame. And then we're going to add a window listener, and then it's going to be a new exit listener. And then on the window listener, we're going to run a system.exit. So when we click the little close, it'll close the window and exit out. If you run example number 3, you'll see that happen actually, in terms of extending the closable frame. So event processing, getting into that concept here under the controls, characteristics versus windows on the GUI controls. Automatically drawn, you don't have to override paint. You don't actually have to call paint at all in terms of the graphic 2D stuff, positioned by the layout manager, and you can use the native Windows system or the controls for the widgets. Higher level events are typically used. We put in the event listener. Same thing in the Android environment, actually. You put a listener on a button, you put a listener on a close events, close window, or on a GUI, and you capture the event, and it's what they call event-driven programming or event-driven processing. Centralized versus decentralized event processing depends on where the events are coming from. Component, as an example, from a decentralized perspective, components like buttons can have their own listeners. We put it on a button. Versus centralized, listening on the entire app or listening on the entire interface, so the main app listener. If you were in the Android class, we saw that a couple weekends, actually it was last weekend, we looked at the event listeners, and there's all of the different ways of putting listeners, using a listener model, actually, design pattern, on the app itself, either for background presses or for component presses. It's the same in the non-Android environment as well. Semi-centralized event processing using the inner class for the event handling, better than the interface for many different buttons. So here's an example of the decentralized one. So we're putting it on. Add it to this button, add it to another button, add it to another button, and then set the resize. So set size button. So we put 3 buttons on there. We put 3 different events on there. Or if we listen to it. So this is the action example 1, and here's where we're going to implement the action listener. So in an Android environment, we extend button, implement action listener. Same thing in the non-Android. It's just the Java programming that is the listener. So we have button listener, clicked item listener. In the Android environment, we have all of the different listeners that are extended from the action listener. So we can have a button listener, click listener, on list change, on close, all these different types of listeners that we add on there, which are just all extensions from the action listener class. So if you take the basic concept, extend some libraries that are specific to Android APIs, stick those classes in there, and all of a sudden you have Android, which is what you get with a lot of the other Android classes and functionality as well. So the action performed, which is the same thing you get as well. So on click, and then you have the action performed method that's extended from that. That's inherited from action listener. So it's part of the implementation of the interface, going back to the interface context in terms of taking and implementing the method prototypes are part of the interface. So if we don't implement the action performed, we don't implement the interface correctly. I believe this only has 2 methods in it, or 1 method, depending upon which interface you're implementing. Action listener only has 1, which is going to be the action performed. And if you run the example, you get the different implementations of what happens when you click on the buttons. Versus the centralized. So it's a bit tedious, but if you break it out, decentralize it or centralize it, put it so you're adding the listener on all of the buttons. And then, same thing we did before, we can add a listener. Actually, we can take and add a click event. We can do the same thing as we did in Android a couple weeks ago, or a week ago. We can add the click event to the buttons, add the listener to the entire app, or add them to each one of the components individually, which is what this is doing in centralized versus the decentralized. If it's centralized, it's put on all the components. When something comes in this particular case, we're going to get the source. So in here, the action performed, the process is the same, except we just put it on the entire class object. And then button 1.add action listener to this. And then when we get a button click, if it's on a button, you know, what button is it? It's button 1, button 2, button 3. So we get the source and we say, okay, if it's this button, do this. If that's button, do that. So it's centralized versus decentralized. I don't think of it in terms of central versus decentral. I think of it as on all of them together, or as on each one of them individually. So, which is kind of pretty much the concept. And if we look at this one here, we had the same example done for the decentralized or the semi-centralized event, where we're going to use a combination of both. So We can put it on one item or we can put them on all of them. Here we have a resized event listener. I'm going to update the layout to change the height and width, I believe, of the window depending upon which button we click on. So it's going to take the height and width measurement, send it to a resize handler. So on the action performed, it's just going to update the height and width that it receives. So. Buttons. We have labels. We have all sorts of different components. The button itself is probably the most common. In terms of the constructor, we can just say button, or we can say button with this label on it. We also have ones that are inherited from button for image button. So we can put an image on a button. Clickable, selectable buttons, non-selectable buttons, all sorts of different types of things that you can extend yourself, which is the same thing you can do in the Android environment. You can create your own component using the existing components by inheriting from them. Retrieve or set the current label on the button. What else can you do? Well, you can retrieve properties. You can add it to the container. Here's some button.setLabel, setParent, validate, which is, you're going to make look selected, not selected, clickable versus not clickable, shown versus hidden, kind of thing. And the event processing, it responds to, as we've seen in the above examples, the action performed event. So that's the event that's going to happen with the handler. And then the general methods are here that are inherited from the component for the get foreground, set font, get font. And here's the example. Here, if we look at this, we've got an applet that has 3 buttons on it, button 1, button 2, button 3. Looks the same in an applet as it does in an application as it does in an Android program. The only thing different in the Android is you're using the XML translation from the XML screens to the Java code. So it's a slightly different way of creating the buttons. You can actually create them programmatically, however, without you writing any XML code. You're not using any tag components, as we've seen. We saw that in the Android class, actually. The handler button events here attach an action listener to the button and handle the event for the action performed, which is the same thing we did in the Android class, actually. We just essentially implement the action listener and stick it in there. Stick the method implementation in there, which is action performed. The only method that's in the action listener interface. And then we can go b1.add the action listener to it. So, not going to go through the entire AWT components, but another one that's used a lot, as these are just examples, there's only a couple more left here, are the checkboxes. Checkboxes also have constructors with them. We can have the standard checkbox, the checkbox with a label on it, a checkbox with a Boolean state, whether it's selected or not selected. But you're going to get the same thing with the radio buttons, and we went through that actually in the Android class in terms of those components. But it's the same. Here's an example here. This one is called the Checkboxes example. And you can load this up and look at the Java source code. It's included in the source code file that I provided for you. So you can take a look to see how those are created. And it's actually quite simple. You just make an instance of the object component itself. Making sure to import the button with the AWT class package. We can get the state, set the label. In fact, actually, it's kind of interesting is, when you click the box, the label can change. Say, done, or submitted, or something, when you click it. Or you can have it so you click it and it doesn't select it. Which is kind of like those candles you blow out, but they never go out. So, I'm clicking on it, but it's not selecting. It's because it won't let you select it, because you have to do something else first, or something. And you can really trip up the user with those things. What I don't like is when they take these and they make them into radios, so only one of them can be selected. So you click one and the other one's deselect. No, I wanted to select them all, because checkboxes are supposed to be multiple select and radios are single. But some people like to switch it around. So you can do it. All you can do is change the state. One of them clicks, take the rest of them and unselect them, which is not so good. And then you can add an action listener to it. So you have an item listener, like a list item or an item change or a state change listener. And then you attach the code to the listener. And you can deselect all the other buttons when one button is selected or something. So in the item state changed method. Identical to the way it's implemented on the Android. So you can also ignore the event as well. Checkboxes and radio buttons are the groups for it. Again, the only way you can really learn this stuff is to practice it, to play around with it. So I highly recommend playing around with the examples. But here's an example of the radio. They're just round instead of squared. But the functionality is supposed to be that you can select multiple flavors and then only one topping or something. Yeah, so multiple versus, but you can change the behavior around. And we have checkbox groups that exist as well, so you can group them together, which means you can select more than one in a group or just one in a group. So. List boxes. The list box example, you can add vanilla, chocolate, and strawberry to a list, and you have a drop-down list. So this is review again from what we've seen in the previous weekend. So other list methods add multiple modes. So you can have select multiples instead of just a single item in the list. Remove one, remove them all, get the selected index. You're probably going to want to know what the user selected on, and then add an event listener to that. So you can add something to it. Say, hey, I selected all of them, or I only selected one or two of them. Okay. Here's your other GUI controls, a choice list. You open it up and expands out. Text fields and forms. You can create, some input fields, some check boxes, a label that looks like a text box by just putting a border around it. All sorts of different things. And our text area here, okay. Interesting labels over here as well. So in summary, this was just another look at to review the concept of AWT and swing, looking at different things than we looked at originally in the first weekend. So this is kind of the conclusion in terms of the graphic component parts. Is the native components behind the scene. So all of the windows and graphic components are rectangular and opaque, and they all look and feel like the underlying operating system, theoretically. But most people can tell, especially if you're using AWT, you can tell if it's a Java interface. It looks like a Java interface. So if you use the swing and you can kind of get at the underlining and use the native support, you can actually use a combination of different techniques to make it look like a Windows or a Mac program. And we saw that with about 3 or 4 different notepads that we made last weekend, or the last time we met. The windows themselves are the canvas, which is the drawing area, the custom components. And then we have the panel, which is the grouping of components. And then the frames with pop-up windows and things. And then we've got our GUI controls, our buttons, and our button handlers, and our event listeners, and our action listeners. So we put a listener, we use a listener model on the components, and then we respond to events and have event-driven programming. Listbox, quickly determining the event handler for a component by simply looking at the API online. You can do that. Nobody sits there and memorizes all of the different components, nor do they memorize all of the different interfaces to the components for the action listeners. Instead, you figure out, what is this I need? And then you locate it and you go, oh, I need to put a listener on that. Knowing that you need a listener is kind of an important concept. You don't get the automatic behavior. Which is kind of funny because in the iOS you don't put a listener. We don't use a listener model, which is interesting. It's on there automatically for you. So why didn't do that to Android or to Java? I'm not quite sure. But it could be that Java came first maybe and iOS came second. I don't know. Actually, if you think about the history of the languages though, Objective-C was around a lot longer before Java. But it's the implementation. So you have a little bit more manual control over the activity, I would say, in the Java environment. Maybe not as much control, but you have higher level features on the iOS platform. So you actually have to put a listener on, but you have to figure out, well, what's a gesture versus a click versus, and then trying to capture what it is you're looking for. You can put a listener on gestures in iOS. Do we have gestures in Android? I don't think we do. If we do, I'm pretty sure there are some, but it's not. I can't imagine it being as extensive. So anyway, again, that was your. Today was all about reviewing for tomorrow. So and that was your AWT and your graphic stuff. I have another one, but I think I'll save it for you for tomorrow. Another one on events, and another one on layouts. Actually, we did this one, we did this one. So I'm going to end this recording.